So thank you for inviting me, Paolo. It's very nice to be here and to speak on a subject that I like very much. So I will keep the politics, and in some sense I will answer to Joe later, and also to the remarks that had just been made on simulation. I just want to show you what we have done with two colleagues. So there are tools to evaluate merger. And I think that right now we can say that the two important tests are the HHI and the UPP. They are on the table. These two tests are not absent of assumption. They are based on economic model and have their own predictive power. So the question is to test their accuracy. There are different ways to do that. Usually, one thing that people are doing is that they are looking at data on a set of merger before the merger, and they look at what happened after. Okay, and they compare by a different type of model, usually what they call difference in difference model, if there are what has been decided is observed. Okay, so if the merger has been approved, we should expect that there was no price change after if the decision by the authority has been correct. But of course, between the time the decision has been taken and when you observe the data after, many things can happen. And it's very difficult to control for this element. And so there is a need to find another way to test for the accuracy of this test. And it's what we have tried here. We try, like, you know, we construct like in chemistry a workbench, and we are going to try to do experiment on this workbench. So create realistic economies and make merger. Use the HHI, or the UPP test, and see if what they are doing. Do they prohibit too much competitive merger, or do they approve too much anti-competitive merger? So what is the level of type 1 error and type 2 errors that these tests are implying? Of course, also because there is always no direct answer. What is important is, in fact, to understand what are the economic conditions leading to higher level of error for these two tests. So to do that, I'm not going into the detail. We are using the best simulation model. Best simulation model means that what we are going to do is to use a demand model which does not impose a constraint on preference demand. So that we try to have a demand model that span all the preference in the economy. So we have all the heterogeneity of consumer here. It's very important, and of course that is based on the random coefficient model, which is itself based on a very important theorem by McFadden, showing that this type of preference model is able to cover a large area of preference. And so in practice, we are going to create each time 10,000 consumers. On the supply side, I agree that it's relatively simple right now. We have 9 firms, each producing one single product. It can be viewed as a strong assumption, but in fact, after when we are doing a merger, this assumption is maybe less strong. Where the strong assumption is that we are using constant marginal cost. A constant, I will say, assumption in all our model, which is, to my point of view, not necessarily true in most industry. But that is, I will say, the normal benchmark. We start with Bertrand competition to evaluate the effect of. Okay, and then we start creating our economies. So we create quality of product, we create consumer taste preference by drawing from the distribution. Then we put firms in front of those data. They have to make prediction on demand, which is quite realistic when they start doing their price, contrary to what we are doing. Usually we are maximizing static profit. Here is expected profit in the sense that they have to make prediction about the demand. Then we solve for price, and then consumer make their choice, and we get the equilibrium. And then in this setup, we create mergers. Okay? And so we recompute each time, if we have a merger, the situation of the equilibrium. And we do that 1 millionth time. Okay, so we have a very, very, very large data set covering a large number of different types of mergers and a large area of potential situation. Of course, that creates some problems, so we need to clean the data set. There are some problems of convergence of the Nash equilibrium, and there are some problem of with extreme value on elasticity, which removes that we need to remove. To give you an idea of the heterogeneity that we are getting, look at the line on aggregate demand. So you see, on altogether, we have the average of the aggregate elasticity on all our economies that we have is minus 1.2. Of course, we are, given that we are in a Bertrand-Nash equilibrium, we should have something elastic. And you see that the minimum and maximum, we can have a situation where the aggregate demand is inelastic and where merger will be easy to approve. So we have a very large range of potential situation. One important thing that happen also is that we observe quite often. We observe a non-negligible number of cases where we observe price decrease after merger. Okay, and so we keep having in mind that there is always price increase, but there are some literature explaining why we can get that at the equilibrium, and in particular, I think that it's important to go back to the paper by Below, Genakopoulos, and Klemperer, where it's a crucial assumption to obtain this negative price result is the fact that products are strategic substitute or complement. But I'm not going to extend on this point. So now we are going to do the HHI. So you know I'm God, so I can make mergers. So I know the true HHI, and I can compute the HHI as the authority is doing, because the authority is computing the HHI pre-merger, computes the post-merger HHI based on pre-merger market share, while we have the post-merger market share, given that we have the true economies. Okay, so we can, of course, make all the comparison. So I'm not going into the detail given the time, but basically, three results, and I will move to UPP because I think that the discussion focus on that. Basically, you can say everything you want with the HHI. Okay, so you see all the point. At the end of the day, if you compute on average the correlation between the industry structure and the possible price increase, there is no correlation. It doesn't mean that you cannot use it, but it means that, of course, the level of type 1 error and type 2 error are very strong if you use HHI. Of course, now we can go a little bit further and explain what it happens. For example, type 1 error, and of course it's intuitive, I guess, will link to HHI, will increase if we have a bad estimation, bad definition of the market. When we say a type 1 error is higher with high market share of the outside good, it means that when we compute we use the market share in the HHI, we use what we call the internal market share of the market, without taking into account that there are possible substitution from the overall market to the external market. Element that usually is inside what it is called simulation model. In simulation model, we always take into account the possibility of an outside alternative. Okay, so that one of the main reasons for the problem of the HHI is linked to that. It is linked to the market definition. And that's the problem of the process of doing merger. We start with market definition. Why? Because we need to compute the denominator of market share. But what it means is that if you make a mistake here, your HHI is wrong, and then the decision based on that is going to be, of course, strongly biased. So I don't know exactly where I am, but I think that I should move. Okay, so there is also some type of result for type 2 error, and of course it's the reverse. So I'm moving to the UPP. And again, we are going to be able to compute the UPP and to know exactly the true UPP, because we know the true economy. So I recall the formula that you have already seen. So it comprises a diversion ratio, a pre-merger markup, and element of cost efficiency, and the rationale is very simple. UPP is indeed the balance between the increase of market power, it is contained in the diversion ratio, and efficiency gains from the merger. So I think that indeed, and I agree, the nice element of the UPP, it is this pedagogical message, because it summarizes the trade-off that is inside an merger. And I think that to be convincing, it is very simple. I think that any element of this formula are understandable, and so I think that the message, in particular to the lawyer, is simple to use with the formula. Now, The thing is, in practice, there are many more formula for the UPP. Joe and Carl have proposed another one which takes a little bit more of the substitution between products, so that's what we call UPP2. Schmalenzi also has another formula to take into account not only the efficiency from firm I, but also the efficiency obtained when they merge with firm J. And Epstein and Rebelfel have another formula which is closer to the computation that are implicitly what we do, the precise formulas that we do when we do the merger simulation. So, and so we are going to consider this different UPP in the study. Now, the problem is that there are many elements. So first, you need to measure the diversion ratio. You need also to measure the pre-merger markup. So we did not speak about this problem, but I think that measuring marginal cost is something not so easy. To my point of view, and given all the discussion I could have with people in the industry, usually what they are having is evaluation coming from accounting, and accounting marginal costs are quite often completely different from what I will call economic marginal cost. That is to say that marginal cost that we will recover from the estimation of markup using demand system. So I think that already it's already a lot of problem. But of course, one of the two problem is the evaluation of the pass-through rate. So because of the formula, I'm not going into the detail, but the change of price due to the merger is linked to the evaluation of the UPP, but also to the pass-through, that is to say how much of the price or of the cost of the efficiency is passed to the consumer. And there are discussions about what is the right pass-through, and Paquet has proposed that we use one. On the diversion ratio, I totally agree with Thibault. There are different ways to estimate it. So one very simple way to estimate the diversion ratio is what I call the logit diversion ratio. Is simply the ratio of market share. So you see, if you compute market share, you can compute easily diversion ratio, but then you transfer the problem of measuring market share to the measure of diversion ratio. And really, I think that is so simple that I don't see how an authority will not do that. And it's so tempting to do it that I'm pretty sure that this diversion ratio will be first used before using what Thibault has proposed, that is to say, look at what people will say in terms of revealed preference diversion ratio. That is, you ask them how much you are ready to buy if there is a change of price. Well, I'm doing a lot of things on transport. I know, and in transport, we usually ask people about whether they are going to take the bus or their car. Okay, and there are people doing this type of survey. We know that usually, if you ask them compared to what you observe, the usual numbers that we have in mind is that the difference between revealed preference and stated preference is 30% on the probability. So it means that the errors that you can make on the measure of the market share is 30%. So really the problem of understanding the effect of this approximation on the accuracy of this test is on the agenda. And so that's what we get for the different UPP. So as you can see from at the first glance, they are not too bad. I mean, a lot of points are around the 45 degree line. Although you see that the cloud is quite sparse. Probably you see that the UPP of Epstein and Rubinfeld, in some sense, is doing better, and it is true. This table, in fact, summarizes our results. If I knew all the market share, if I knew the true diversion ratio, if I knew the marginal cost, okay, what we get is that UPP can predict price increase almost completely, 98% with the UPP by Epstein and Rubinfeld. Okay. If I take another situation where I use for the diversion ratio computed according to the logit formula that I show, if I'm doing some estimate on the marginal cost, then usually UPP predict around 35%, 36%, say 40% of the real price increase. Okay, so that summarizes the idea. Now, what will play a crucial role here is not the pass-through rate, okay? So if you make a mistake on the pass-through rate, it will not change too much the results, is what we have observed. What matters a lot is your evaluation of the diversion ratio in those formula. And clearly, it seems that the formula that should be used is UPP2, the second formula proposed by Joe and Carl, and the one used by Epstein and Rubinfeld. So that's it. So to conclude, so you see, and I'm going to change my conclusion to introduce the discussion with respect to what Joe and Thibault have said. I think that we should not put on the same level simulation model and HHI and UPP test. HHI and UPP test are useful to debug the situation, okay, and to give you an idea. But clearly, you know that there are mistakes. Simulation model, it can be wrong in the sense that it's an approximation of the situation. But it will allow you to evaluate different situations, okay? I am taking an example now, which is that comes from one of my first experience with this model. Is the case of the Volvo Scania case. In fact, with Frank Verboen, we have been able to convince the Commission that the simulation model was interesting, not because we said, look, the price increase is going to be high if Volvo and Scania merge, but what we have been able to show is to say that if you allow Volvo and Scania to merge, you will not be able to block or to prohibit a merger between Renault and Iveco, or a merger between MAN and Daimler. And if you observe the situation, it was able to show that you will have, in this situation, if they have accepted this free merger, that they were on, the industry were preparing this merger, you will have a merger in the north of Europe, a merger in the south of Europe, a merger in Central Europe. And so instead of having to, all this merger will have been against, in fact, market integration, because they will monopolize the situation in free market, okay? And so you cannot do that with HHI and UPP test. I'm not saying that I think that the model, and I can tell you, I think that the model that we use for Volvo and Scania is really basic. But I think that being able to put this type of, and to show this type of argument is very useful. So now the problem is to say, well, we need a lot of data. Come on. We have computers, we have now more and more sophisticated method to estimate. I don't think it is the problem of dealing with a lot of data. And as Thibault said, when you start estimating a demand, you already have collected a lot of data, so that it's natural, I will say, to go a little bit further to estimate a full model and to have a demand and supply model, and to be able to really analyze the functioning of the industry. I think that, contrary to what Joe said, it's very important to have a model that tells that you are estimating something from the industry. You cannot use the chocolate model to speak about the steel market, okay? And if you are able to show that you have estimated a demand model for the steel industry, and you are using it to simulate the price increase with this model, it's a little bit better. Thank you very much.